volume of revolution. Volume of revolution. What is this volume of revolution? Suppose I have area included between y equal to f of x axis, x equal to a and x equal to b. Suppose I have some area. Okay, I have some plane area included between the curves y equal f of x, x axis, x equal to a and x equal to b. If this area is revolved about x axis, then it sweeps a volume called as volume of revolution. Okay, if this area is revolved about x axis for 360 degrees, this area sweeps a volume. What would be that volume of revolution? That is one question. Second would be, what is surface of revolution? What is surface of revolution? Surface of revolution means for this area I have a surface here. Only for this surface I am talking. If this surface is revolved about x axis, gives us another three-dimensional surface, a curved surface. What would be the surface area of revolution of that surface? Okay. In fact, the same object when revolved about x axis gives us a volume. For that volume, I have a surface. What would be the surface area of revolution? Two questions. Okay. One. When I talk about volume of revolution, what I'm going to do is I will try to consider a strip at some x. This is dx, suppose. Okay. The height of the strip, since it is x, the height of the strip would obviously be y. I can treat this as a rectangular strip. If this rectangular strip is revolved about x-axis, gives a circular disc of certain volume. What would be the volume of that circular disc? The volume of that circular disc will obviously be pi y square dx. Let this take a line. Only take this y height line. Y height line. Okay. Let that line be revolved about x-axis for 360 degrees. Gives a circular area. What is the area of that? Pi y square. Y is the radius, pi y square. Like that, I have dx thickness. I have so how many such areas are there? Pi y squares are there. Dx pi y squares are there. Okay. So pi y square dx gives us the volume. It's a kind of a cylinder basically. Cylinder of radius y and height equal to dx. So pi r square h. So pi y square dx. How many such circular discs are there? Infinite number of such discs running from x equal to a to x equal to b, which is an infinite summation, which is an integral, which gives us this entire volume of revolution. This is what is volume of revolution. Integral extending from a to b, pi y square dx. Okay. Now, when I talk about surface area of revolution, what I am going to do is, I will take this small strip here. This is small ds length, strip. Okay. That small strip, when it is revolved about x-axis for 360 degrees, it actually generates a surface. It's a surface is a kind of a ribbon kind of a surface. Okay. What is the surface area of that ribbon? That ribbon would be 2 pi y ds. 2 pi y ds. Okay. D small s, capital S ante surface. D capital S means it is surface already. I am not talking about capital S. I am talking about small s here. Okay. Surface kada. It inclined untadi. X itlunthundi. It inclined. So length of the curve I am taking there. ds. That small infinitesimal very small length of the curve ds is revolved about x-axis for 360 degrees, which gives us a ribbon kind of a surface. Okay. Ribbon kind of a surface. That surface area would be 2 pi y ds. How many such strips would be there? Infinite number of strips running from x equal to a to x equal to b. What is ds first of all? Integral a to b, 2 pi y. You can, if you try to convert this into parametric notation, you can write a ds by dt, which would be ds by dt square root of 1 plus dx by dt whole square plus dy by dt whole square. So obviously, t running from TA to t running from TA to t, extending from a to b means t would be there for that parameter x equal to a, so TA. For the parameter x equal to b, t would be tb, so TA to t. That would be the surface of revolution. Take some questions. In fact, these are very, very simple questions, but you should know certain things here. Take this. Find the volume of the solid. obtained by revolving, one arch, ARCH, one arch of the cycloid, x equal to a into theta plus sine theta, y equal to a into 1 plus cos theta. How does this cycloid look like, first of all? This is called cycloid. Now, this is all about cycloid. How do you obtain cycloid? Suppose I have a line, straight line, or a road. Suppose, assume there is a tire here, tire is a circle, okay? For this circle, take this point P, suppose, okay? Let this cycle move along this line. Let this circle move along the line. What happens? This point also moves, okay? The trajectory of this point would be like this, and again goes like this, and again goes like this, and keeps. That trajectory is called as cycloid, okay? The trajectory is called cycloid, okay? You take any point, whatever point you take on the circle, it always goes in this manner, okay? All of them form only one cycloid, okay? This is called a regular cycloid, simple cycloid. The equation of such a cycloid is given by like this, okay? X equal to a into theta plus sine theta, y equal to a into 1 plus cos theta, okay? And this is theta equal to 0 case. This is theta equal to pi. This is theta equal to minus pi. Okay. This height of this actually is equal to 2a. So this length obviously would be a pi. Okay. That length actually would be a pi. Is that okay? Matching? Now, this is one cycloid. There are different cycloids. You know, hypocycloids, hypercycloids, like that. Suppose I have a big wheel kind of a thing. Okay. On which suppose a small circle just rotating about this, okay, then the trajectory of a point on that circle when it moves along this, it would be something like this, is it or not? Okay, sometimes it would be inside also you can have something like, so one is hypocycloid, the other is hypercycloid. Where do you find these scenarios? Mechanical engineers, you see, engineering drawing, okay. Even in your watch also, we have big wheels, small wheels, another small, so many things. So, why this is used actually? Why this kind of thing? In idea? Why we require this kind of physics? When you learn this physics related topics, certain kind of motions, translatory motion, rotatory motions, helical motions, cycloidal motions, you should know what they are. Anyway, so we have taken only one arch of the cycloid. Actually, there are 4 types of cycloids again. All the 4 you should know. So, x equal to a into theta plus sine theta, y equal to a into 1 minus cos theta, x equal to a into theta minus sine theta, y equal to a into 1 plus cos theta, x equal to a into theta minus sine theta, y equal to a into 1 minus cos theta. There are 4 cycloids like this. Okay, this is one cycloid. Similar kind of a cycloid is this is x, this is y. Just a translation of a pi distance. That's it. Other 2 would be, okay. So there are so many arches. It's not only one. It goes like this, like this, like this, like this, like this. Of which I am taking only one arch. This is one arch that I have taken. This belongs to this one. 4 drawings, 4 curves equations. Match the following, integral matches. Now, why I am showing all these 4 cycloids is only one reason. Question would be here, if you look at this one, what is the volume of revolution of this cycloid, one arch of the cycloid about x-axis, okay? So, this is the area between y equal to f of x-axis, x equal to a and x equal to b, revolved about x-axis gives us volume of revolution, okay? Same thing if I revolve this one, y equal to f of x-axis, x equal to a, x equal to b. Now it would be this area, is it or not? That area revolved about x-axis gives us another kind of volume, not this volume. So don't think like all the cycloids when revolved about x-axis gives the same volumes. No, they are not the same volumes. Okay. Now it would be this one. Okay. Sometimes the question can be for this cycloid, if this area, other one, If that area is revolved about x-axis, what is the volume of revolution? Understanding that? What would be the volume of revolution? Of course, it's the easy aspect because I will first revolve about x-axis this entire rectangular area minus this area when revolved gives us the volume of this one, volume of revolution of this. Understood? It's the same thing. So first you should know like what is the question first of all. What is the curve that is given to you? How it is oriented in xy plane. If you know that, then things should be easy. For example, this area revolved about y-axis, getting that? Revolved about y-axis. It gives us a separate another kind of volume of revolution. Like that, surface areas of revolutions also. Different surface areas of revolutions will be obtained by different cycloids with different axes. So it's not all of them together as one. No. They look like similar, but they are not exactly the same when revolved about x-axis. But the only things which are same is what is the area included, what is the length of the curve, or what is the area here. That might be the same. That might be the same for all of them. But when it comes to volume of revolution or surface areas of revolution, things would be different for each one of them with respect to different axes of rotation. Are you getting that? So you should know what is this, and what is this. So go home and try to match them. One of them I have given you already. This is what I have given you. Okay? Based on that hint, go home and try to match the following. Understood? Okay. Now, how to find volume of revolution for this one? So volume of revolution for that one would be quite obviously V equal to integral pi y square. Y square is a square into 1 plus cos theta whole square into dx, which is a into 1 plus cos theta d theta, and theta running from minus pi to pi or 0 to pi 2 times. Theta running from 0 to pi 2 times. Understood or not? Okay? Whatever it comes out to be, you go home and try to solve that. If you want actually to use beta gamma functions also, you can use. Not gamma function, beta function you can use it here, but it's up to you because I have already given you one formula in beta function there. The answer comes out to be 5 pi square a cube. 5 pi square a cube. Don't worry, these questions actually we are not getting these days, so it doesn't mean that they are not part of your syllabus. They are definitely part of your syllabus. Okay. Find the volume of the solid obtained by. Revolving the cardioid. R equal to A into 1 plus cos theta. About the initial line. Again, there are 4 cardioids. Anyone who remembers cardioid? Okay. 4 cardioids are equal to A into 1 plus cos theta, R equal to A into 1 minus, R equal to A into 1 plus sin theta, R equal to A into 1 minus 4 cardioids. Here the dimensions, this is 2A, A for all of them. Again, match the following. Why we require to know again is, it's not about areas or length of the curves. Okay, you can also find length of the curves and areas also, not an issue at all. But when it goes to volumes of revolutions or surface areas of revolutions about initial line means x-axis, theta equal to 0, 1. Okay, what you are going to get is something might be different for each one of them. Okay, so that's the point. The answer comes out to be 8 pi a cube by 3. 8 pi a cube by 3. Okay. Take this one. Surface area. Theta equal to 0 and initial line. Take initial line again. Theta equal to polar system. Remember the polar system, the terminology. So polar system has 2 things. One is the pole, we call also the focus, or initial line. This is initial line. Initial line actually is theta equal to 0 line. Okay. Any point P, x comma y, actually in terms of polar system is represented in terms of r's and thetas. Okay. Its distance from origin is r, called as a radius vector, and the angle we call it as theta, vectorial angle. Okay. So with respect to theta and r that we define polar system points, r's and thetas, vectorial angle, and initial line is theta equal to 0. That means the question actually asks you to find what is its volume of revolution or surface area of revolution about x-axis is something which he mentioned. That's what it means. when he mentioned about initial line. Take one last question here. Evaluate the surface area of the solid. Evaluate the surface area of solid generated by revolving the cycloid x equal to a into theta minus sin theta, y equal to a into 1 minus cos theta, about the line y equal to 0. About the line y equal to 0. Answer 64 pi a square by